it's too hard?
I'm gonna push through.
What if it's too long?
I'm gonna push through.
What if it's too tough?
I'm gonna push through.
What if you're just too young?
That's not true.
What if you're not good enough?
That's not true.
Why? Because
I can do anything I put my mind to.
I believe in you.
Chin up,
Believe in yourself.
head high.
Tell me why.
We push through anything we put our mind to.
Good morning, grade 5 students. Welcome back to another teaching and learning exercise. This morning we will be looking at the subject mathematics and the topic different types of sets. Now here's a beautiful definition of sets. Now a set is a collection of objects usually of the same kind, and these objects are called members or elements of the set. Now they can be numbers, letters, symbols, games, object, or anything you can think of. And here are two beautiful examples of sets. Alright, so we have set A and we have set B. Now let us go back to the first sentence in the definition. It says a set is a collection of objects, usually of the same kind. Now if you look at set A, we see that set A is a set of fruits. But in set A, there are different kinds of fruits. But they are all fruits. So therefore, they are all of the same kind, but they are different fruits. Alright? So set B is a set of shapes, but they are all different kinds of shapes in set B. So they are all of the same kind, alright, because they are all shapes. Alright, go back to set A. In set A, we have banana, we have orange, we have apple, we have pear, we have mango. I hope I get them right, etc. Alright, they are all different kinds of fruit, but they are all of the same what? Kind. Same with set B. Set B are a set of shapes, but they are different shapes, but they are all of the same kind because they are all shapes. Now in set B, we have a triangle, we have a square, we have a rectangle, we have triangle again, we have hexagon, we have pentagon, we have heptagon, and we have some irregular shapes there. So all are shapes, right? But they are different kinds of shapes. So that means they are all of the same kind because they are all shapes. So in set A, we can't have shapes and fruits and call it a set. In set B, we can't have shapes and fruits within the same set and call it a set. All right, they must be of the same kind, just like set B, which consists of shapes. All right, but there are different kinds of shapes. So that makes them that makes set B the same kind. Set A, same thing. Set A have different kinds of fruits, but they are all fruits that make them the same. All right, good. So these objects are called members or elements of the set. And they can be numbers, letters, symbols, games, object, or anything you can think of. So these fruits within set A are called elements or members of set A. All right, they are called elements or members of set A. Set B. These shapes within set B are called elements or members of set B. These shapes in set B are called elements or members of set B. All right, great. Now, the members or elements of a set must not be repeated and must be enclosed within a curly braces or brackets. That's an example here. All right, to show that we are considering many objects as one set. Now, uh, for example, let me go to my board. I have 2, 4, 6, 8, 10, 12. All right. So look at these numerals and numbers. All right. Look at these numerals and numbers. Numeral 2, numeral 4, numeral 6, numeral 8, number 10, number 12. All right. We can represent these numbers and numerals as a group. All right. We can represent them as a group. All right. So we can group them as a set by putting a curly braces or bracket here on one side. Let me represent it right. All right, let me, so I can represent it right. All right, so and another curly bracket or brace right here. All right, so here now we represent these numerals and numbers as one set. Now we can call this set, we can call this set B. So we can say now set B is a set of even numbers. All right, we can say that set B is a set of even numbers. And what are even numbers? Even numbers are numbers that are divisible by 2 without leaving any remainder. What do I mean by divisible? 2 can divide each of these numerals and numbers without leaving a remainder. All right, so 2 can go into 2 without leaving a remainder. 2 can go into 4 without leaving a remainder. 2 can go into 6 without leaving a remainder. 2 can go into 8 without leaving a remainder. 2 can go into 10 without leaving a remainder. And 2 can go into 12 without leaving a remainder. All right, so we can say that set B is a set of even numbers. All right, so this is how we represent our set. All right, now here's another example to make sure that you understand. So here I have J, and always put your comma. I have K, I have M, and N. So these are letters, and we want to group these letters as one set. All right, we're going to group these letters as one set. Now first we have to enclose it with our curly brackets. So we have to enclose it with our curly brackets. And here am I enclosing my letters with my curly brackets. All right. So now I make my set, and I can call this set set D. All right. Here's my set D. So I can say that set D uh, is a set of consonants. All right. So set D is a set of consonants. What do I mean by consonants? Any letters that are not vowels or consonants. All right. So I have A, E, I, put my dot here, I, O, U. All right. Alright, so any letters that are not vowels are consonants. So here are the vowels. Here are the vowels. So we have A, E, I, O, U, and sometimes Y. So here are the vowels, and none of these letters have A, E, I, O, U in it. So therefore they are consonants, because any letters that are not vowels are consonants. So therefore J, K, M, N are consonants and not vowels, because the vowels are A, E, I, O, U, and sometimes Y. Alright, so we can say that set D is a set of consonants. Alright, and this is how we represent our sets. Alright, our set. Okay, so the definition says that the members or elements of a set must not be repeated. What this means, that the members or elements of a set must not be repeated. Let me give you an example of this. All right, so here I have the word carbohydrate. So I have CRBOHYDRATE. Carbohydrate. So call that word carbohydrate. That's a big word, right? Look it up in your dictionary for me. So we have carbohydrate, and over here we have the word mathematics that we are doing right now. So mathematics. So we have mathematics on one side and we have carbohydrate on the other side. All right. Now let me draw a line to separate them. All right, good. So if I should say to you that I want you to represent a set of vowels from the word carbohydrate. All right. Represent a set of vowels from the word carbohydrate. Now I can say that I can write down the letters of the vowels from carbohydrate. I can write A, O, and I can write E. So these are the letters of the vowels from carbohydrate, all right? And I can enclose them with a curly bracket, all right? Now, if you notice how I represent my set of vowels, in the word carbohydrate, there are two A's, all right? There are two A's. But if you notice, I write them back. I don't write two A's to represent my set. In my set, I don't have two A's, right? I have only one A. So therefore, I don't repeat the elements. So that's what it meant by, let me go back to the definition. All right, it says the members or elements of a set must not be repeated. So therefore, I don't repeat the vowel A. I just write it one time. All right, I don't repeat it. So this is how I represent my set of vowels from the word carbohydrate. So I have now a set of vowels. All right, a set of vowels. What about mathematics? Suppose I say you should represent a set of consonants from the word mathematics. Now I will write down all my consonants. So I have M, and I have T, and I have H, I have I. No, I don't have I. I would have C, I would have S, right? Am I missing anything? So M, T, H, C, S. All right, so I enclose my consonants with my curly brackets. All right, so let me put my comma between the letters. All right, so good. If you notice, if you look at the word mathematics, it has two M's, right? Two M's, two T's as well. All right, two T's. But if you notice how I represent my set of consonants, I write the M one time. I write the T one time. So this is how I represent my set of consonants. We don't repeat the members or elements of the set. All right. So we don't repeat the members or elements of the set. So we go back to the definition that says the members or element of a set must not be repeated and must be enclosed with a curly braces or bracket. We just did that to show that we are considering many objects as one set. All right. All right, let us move along. All right, so it says, what is finite and infinite sets? What is finite and infinite sets? Now, a set can either be finite or infinite. Now, in a finite set, the elements can be counted and named. Or we could say that the set has a specific or definite number of elements. What do it mean? What does it mean by definite? Definite simply mean clearly stated. All right. So let me read it again. A set can either be finite or infinite, and in a finite set, the elements can be counted and named. Or we could say that the set has a specific or definite numbers of elements, and we say definite means clearly stated. All right, in this case. All right, clearly stated. All right, so we want to look at the example of a finite set. We want to look on an example of a finite set. All right, so for example, let me clear my board. I want a new board. Can I get a new board? So, for example, I would call this set F. All right, call this set F. So in set F, I would have the set of letters, in the word poetry. All right, in the word poetry, let me put them all in capital letters. All right, poetry. This is what we are talking about now. All right, so I have set F is equal to the set of letters in the word poetry. And let us go back to the definition quickly. Now the definition says, in a finite set, the elements rather, can be counted. In a finite set, the elements can be counted and named. Or we could say that the set has a specific or definite or clear state number of elements, or clearly stated number of elements. All right. Now, set F would be a set of finite. Set F would be a finite set because we can count the letters in the word poetry. And in the word poetry, we have 6 letters. 1, 2, 3, 4, 5, 6. And we can count all the letters in the word poetry. So therefore, uh, the word poetry is a finite set. All right, the word poetry is a finite set because the letters can be counted. All right, it is specific, it is definite, and it also can be named. So therefore, uh, the word poetry is a finite set and not an infinite set. Let me give you an example and see if you understand. So I have set H, all right, and I'm not going to write it out like where I write out this one. I will just write out this, all right. I just write this here. All right, so set H is equal to a set of counties in Jamaica. So set H is equal to a set of counties in Jamaica. Who knows the counties in Jamaica? So the counties are what? All right, I hear someone says Cornwall, Middlesex, and Surrey. All right, so we have Cornwall. This is the counties of Jamaica, or counties in Jamaica. Cornwall, Middlesex, Cornwall, Middlesex, and Surrey, or Surrey. All right. All right. So these are the counties in Jamaica. So set H is equal to the set of counties in Jamaica, and these are the counties in Jamaica. Can it be counted? Yes, we have 1, 2, 3 counties in Jamaica. Is it named? Yes. Is it specific? Yes. It is definite. Is it definite? Yes. It's clearly stated here. So set H equal a set of counties in Jamaica. So therefore, this set would be a finite set because it can be counted. It is named, it is specific, it is definite. All right. So we have 3 counties in Jamaica: Cornwall, Middlesex, and Surrey. So we are counting it: 1, 2, 3. So it is a finite set. All right. Set of counties in Jamaica are finite sets. All right. All right. So let us look at infinite set. Infinite set. So just look at finite. We're going to look at infinite now. So an infinite set, in an infinite set rather, it is not possible to count or name all the elements in the set because the elements are too many to count. All right. So that's the opposite of finite set. So an infinite set, it is not possible to count or name all the elements in the set because the elements are too many to count. And we're going to give the example of this. All right. So an example of this can be, I want a new board. I want a new board. All right. Fresh and clean. Now, go back to the definition again. It says In an infinite set, it is not possible to count or name all the elements in the set because the elements are too many to count. So an example of this would be, call this set K. All right. Oh, I'll need my red marker or red pen. So call this set K. So set K is equal to, and we can say that the set of odd numbers greater than 5. Let me write this out. So the set of odd numbers 5. I enclose it with my curly bracket. So set K is equal the set of odd numbers greater than 5. Now, what are odd numbers? Before we move on, what are odd numbers? What are odd numbers? So if the number is not, or the numbers are not even, they are odd. Always remember that. If the numbers are not even, they are odd. Just soak that in. So, in other words, they are divisible by 2, leaving a remainder of 1. Alright? So, odd numbers are divisible by 2 and it leaves a remainder of 1. So, odd numbers are not even. Just always remember that. The opposite of even numbers, odd numbers, they are not even. Alright? So, for example, odd numbers can be 1, so 3, sorry, what should be here, 5, we can say 7, we can say 9, and the list goes on. All right, bam bam bam. All right, good. So if they are not even, they are odd numbers if they are not even, and they are divisible by 2, leaving a remainder of 1. That is the definition of odd numbers. All right, they are not even, they are odd. All right, good. So set K equal the set of odd numbers greater than 5. Is this a finite or infinite set? Yes, it's a infinite set, because guess what? Infinite set goes on and on and on and on and never stops. All right. So the set of odd numbers greater than 5 will go on and on and on, and it will never stop. It cannot be counted. All right, because it's too many to count. Can't count the set of odd numbers greater than 5. That continue on and on and on. In other words, it is infinity. All right, so you cannot count the set of odd numbers rather, greater than 5. It's too many to count. All right, yes. So bear that in mind. And next example, we can say that set H, we can call it set H. I'm not going to write it out like the second one. So set H, we call it set H, and set H is equal to oh well, I guess I have to write out this one. All right, so set H is equal to the set of I just have to check my spelling for Jamaica, you know. All right, good. All right, so set H is equal to the set of trees in Jamaica. Is that finite or infinite? Oh yes, it's infinite. Can we count the set of trees in Jamaica? No, we can't count the set of trees in Jamaica. That is too many to count. So therefore it is infinite. because it's too many to count and we can't count the set of trees in Jamaica. All right, it's not definite, it's not specific, it's not uh, named. All right, so the set of trees in Jamaica is an infinite set because it's too many to count. All right, so bear that example in mind. Yes, these examples in mind. All right, of infinite sets. All right, so we're gonna move on.